First, let's actually build a project because like this fucking takes forever for a lot of people. So how do you do this? Go into your Unity editor, hit new project, and make sure we're going to be doing a 2D project today. So go into 2D built-in render pipeline, give your project a name, my awesome project, whatever, and then hit this create project button down there. And then that should take a little bit, depends on like how good your computer is. And yeah, okay, so while that actually builds, who the fuck am I? Why am I teaching you? Why should you listen? Hi, I'm Neil, second year CSU, Fall Champs winner. I made this game. Some people liked it. Lead programmer on JSM. A lot of Unity experience and PM evil. So a lot of people say Unity sucks, and this is true. It's run by an evil company. It has slow compile times. Godot like might replace it, and that might be good. And it's a lot harder to learn than Godot, arguably. These are all true, but why should you still learn it? It's statically typed. It's a lot more established. It has a richer ecosystem for now, and it's still the dominant engine in the indie space. And UCI's GDIM program relies pretty heavily on it. So if you're working with like GDIM students, it's very likely that they know Unity, and that's basically it, if they're like lower div. And it handles a lot of mid to large size projects better because of dots and addressables and a bunch of other systems that just kind of scale better. And it's a better 3D engine for you guys when I kind of branch out, although like Unreal is the best 3D game engine, but it's a lot more similar to Unity than it is to Godot. Okay, so today, this text in green is specifically for my mentor students. So like if you're not a part of that, you can just kind of like ignore, but we're going to be using Unity 2022 for our mentor project, not Unity 6, mostly because the new input system is event-based and is a bit more complex, which is kind of harder to teach, and I haven't had the time to learn it enough to the point that I could teach it like pretty well. You should probably learn the new input system eventually, but just not today. I recommend using JetBrains Writer. You can use like literally any IDE besides VS Code because you'll want to kill yourself if you do that. Writer is recommended for a bunch of like Unity specific features and integration and stuff like that. And it's free with your tuition, bro. You get like a free account if you're a student. And it's free for non-commercial use. Okay, so I have a few assumptions going into this about like your abilities as a programmer, because we have to establish like some floor. The first one is that like you're familiar with object-oriented programming in general. So like you know what a class is, you know like the idea of like what an object is in a game. It's not going to like break your brain. You have at least like one statically typed object-oriented language under your belt. So you know like Java, C++, C#, and you have like basic programming hygiene. For my mentor students specifically, AI-generated code is like prohibited for when you're making push requests to the Git repository, mostly because I'm only your mentor for like 3 weeks, and I want you guys to like actually learn. It's not like a principled stance against like AI or whatever. It's just like you guys will not learn if you have your code AI generated for the next like 3 weeks. So try to avoid that if possible. Okay, let's open Unity. So I have this basic project over here, and I want to break it down. So over here you can see we have this thing called the hierarchy. You can kind of think of this as just like everything in your project that's part of your game. So for example, if I make a circle, we can see that appears in the actual game view and is actually visible to the player. This scene view right here is kind of like our view into what's going on with the game, and then this game preview is kind of like a preview of what the actual player will see when they run everything. Down here, this is kind of just like your files for the project. This is like the long-term memory of everything. So this is where your pictures go. This is where your scripts go. This is where your audio files go. And we generally want to keep this nice and organized. Let's actually make some stuff, and first thing we should probably do is make a square. So over here, if you hit right click, you can get this little pop-up window, and you'll go to 2D object, sprites, square. Now, A lot of people, I think, have kind of like a built-in assumption of like how a game engine kind of handles this stuff, and it varies from engine to engine, but the way Unity deals with this is every game object is a box, and the box can be filled up with different things that give it different properties. So, for example, this box is currently called square, but it has this thing on it called a sprite renderer. The sprite renderer handles all the stuff that actually like shows us this gray square, and if I disable it, it goes away. So same if I remove it. Now the thing is, if I were to play my game right now, we would just have a fucking box that's just like sitting there, right? But I can add on components to it that give it more properties, more things that I can do, right? So for example, I can hit this add component button right here, and I can add a rigid body 2D. Everything today we're going to be using is a 2D version, so if you ever have to decide between like rigid body 2D, always go with the 2D variant. Okay, and now if I run my game, we will see, holy shit, it's a box that falls. That's incredible. So, generally, again, Unity works on the system of where we add things to this box. So for example, I add a rigid body, I add a sprite renderer. And that goes for your scripts too. So when you write a script, what you're doing is you're adding another little thing that kind of hooks on to this object. And you're giving it more properties, and you're giving it the ability to like do more things. So I want to go through some like basic like Unity interface stuff. As you can see, I've been moving this thing around with this like move tool. You can see all your tools up here, but really what you want to be doing is you want to be using your hotkeys as much as possible, just because like, bruh, this is so slow. So you have W, which is move, and that is kind of, I guess, the main thing that you're kind of doing. It is how you actually just move anything across your scene. You can grab onto one of the arrows and that will pull it. You then have E, and E is our rotate tool. And you might see this red and green line and wonder what that's about. That's because every Unity project is actually a 3D project that's just seen through like a 2D view. So as you can see, if I were to rotate this, you can see that it's rotating on this view, but from our 2D perspective, it's really weird. Anyway, for that reason, we really only want to use this like blue rotation tool right here to actually rotate it on the Z axis, because we don't want the other two because it just kind of like look weird, and it's likely not what you want. After that, we have the scale tool, which works very similar to the move tool. You can pull and stretch at different angles, and believe it follows the rotation. So if you rotate something, it will still follow like the rotation that the stretching that you applied before the rotation. After that, you have this rect tool, and we're not going to get into this much yet. It's going to become very important when we go into UI. And then you have this final tool, which is like a mix of everything, but like low-key it's disgusting. Don't use it. Just hotkey between whatever you need. Okay, so we have this box that can fall. Let's try making another box that I can like land on, right? So I make a 2D square, and I can make it, I can make a floor for our game. But when I run it, you will see that the top square just falls through the floor, right? And that is because we need a collision, and gravity and physics are kind of different things. So we can have this thing, give this thing the property to fall, which is our rigid body 2D, but we also need to apply a box collider to it. The box collider is basically handles, hey, are these things touching? While rigid body handles more of like, are these things, how should physics be applied to this thing? There's a lot of properties on both, but the main ones that you need to look at is mostly for box collider. You want to keep this edit collider in mind, because you can actually change the like dimension of your box. And two things that collide, both things need to have a collider for that to work. So I run our game again and fall together. We can also mess with the color by looking into, again, our sprite renderer, because that controls everything that we can like kind of see, and we can mess around with the color. Holy shit. Okay, so let's get into like actual like Unity scripting. And let's make a basic player controller so our guy can move left and right. And for this, here's a basic overview of like how the event loop works in Unity. Unity leaves some nice comments here, but like we'll just come back to that later. So first, I want to apply this script to an object to show you guys how that works. So I can apply the script over onto an individual object. And as you can see, I've added a player controller. Now, an interesting thing I can do is I can actually add as many player controllers as I want. Because again, we're just adding on more and more components to our game object, right? So start is whatever code is inside of here will run whenever the game like initially starts, right? So if I say like print hi, and then I run my game, we're gonna see that like hi will print exactly like one time to the console. I get hi once. But if I move it into update, I will get hi printed out continuously. So update is run every single frame inside of your game. And for that reason, hi is kind of expensive, and you don't want to put like really, really expensive functions inside of hi. As you can see, I got 1,000 highs in that time. So first, like general like Unity rule is that you want to cache stuff as much as possible. So we're going to get into like get component and find object by type soon, but generally you want to store values rather than like having to like look them up, mostly because the former is very inefficient. So let's make our guy move. And the way we want to handle that is we want to modify this rigid body 2D. Again, this thing handles all the physics in your game, right? So if we want to do anything with movement, we likely want to use this rigid body 2D in some way. So for this, we're going to start, we can say, hey, I want a public rigid body 2D, and I'm going to call it RB. Now I'm going to come back into this in a second. This is very bad practice, but everything in steps. So that modified our script in our game, and now we can see we have this new property over here where we have a field for a rigid body that matches the name that I got over here. So Unity works on a system of references. So for example, if I write a variable called RB, that means I'm expecting a rigid body reference. Like I need to assign this to something, right? So if I try to do anything with that rigid body without assigning it, so RB dot like, let's say add force, it's going to get very, very mad at me, and it's going to throw back a like big fucking error in my face. And it's going to give you an unassigned reference exception. And it's going to be like, hey, this thing not assigned, right? So there's a few ways that we can get over this. The most simple one is we can basically manually assign it. So we can drag this rigid body component. I can click and drag, and I can drop it in right there. What I could also do is I could click on the circle right here, and I can manually assign it like that. Okay, so let's make blood move right. So in update, what I'm going to do is I'm going to say on my rigid body that I want to set its velocity to a new vector 2. Now vector 2 is just a mathematical vector with only 2 axes. So if I open up Paint or whatever, vector 2 just means I have some value on this x and some value on the y that gives me a new position, right? So I could say, hey, I want this guy to move this way. And for that, I would make a vector 2 that would say nothing, or sorry, something on the x-axis, but nothing on the y-axis because I don't want you to go up, right? So if I want to make the guy move right, I have to say new vector 2, some positive value, and then just no actual y value. And that does actually kind of behave pretty weirdly with gravity, as we're going to see, because you see that he's moving right, but then it's also like kind of falling, and that seems weird because the gravity we had before was like pretty normal, and we also said that like, hey, it shouldn't be like falling at all. And the reason that's happening is this rigid body 2D really, really, really wants the box to fall down. But our loop right here says that we should only be moving right. So these two are kind of fighting, which is leading to that behavior of it like slowly gliding that way, which is like pretty weird and we don't want that. So if we want it to move right, but also to like keep the previous gravity, what we can say is, hey, I want you to move right, but in terms of the up and down axis, I actually don't really care what that is. I just want you to copy whatever value you currently have. So I want you to move right, but don't like edit your Y value at all. And if I was to run this again, we would see, oh my God, TS falls, that's crazy. And it's just gonna slowly carry on right. Now that isn't very useful or like interesting yet because like, I don't know, I want to actually like control my player, right? So this is where input in Unity comes in. So the most basic solution a lot of you might think of is like, oh, okay, if input.get key down a like move left, right? This is pretty unreadable and kind of sucks. We don't really want to use get key down besides for like when it's just like a very specific like action related to a thing. We don't really want to use it for like movement axes. So this would like work and we could say like, hey, if I'm pressing down A, I want you to move left. But this just gets very unreadable very quickly. And I can imagine like, you can imagine other programmers looking through your code and being like, what the fuck is this? So what's the alternative? Well, we can store a vector relating to whether your player is trying to move left or right on their gamepad or keyboard or whatever. And the way we can do that is we can store a vector2 wrong type, a float called we can just call it LR, and that is equal to the input.get axis raw horizontal. So what this line of code means is check the horizontal axis of the player. So that is the up arrow, down arrow, left arrow, and right arrow, and A and D, as well as like a left stick on a gamepad. And if the player is currently holding down D, give me back 1. If the player is currently holding down A, give me back -1. If they're not holding anything, don't give me any value back at all. Now, the reason we use raw specifically is because get axis returns like a smoothed value. So it's like, okay, so the player just started hitting D, so we're gonna find like kind of like an in-between value. And that kind of just feels like really weird for our use case. So we want to use raw because we just want to get, as soon as the player hits D, we want to get back 1. As soon as they let go, we want to get back 0. So we can then say, for every bit in the game, we can just basically say rb.velocity is equal to new vector2 lr, and then followed by just the current downward velocity. And then now, holy shit, our guy should be able to actually like move when we press. Oh my god. But he's really, really, really fucking slow, and we want to make that slightly more usable so our game can actually be kind of fun. So we want to bring in a new value over here, and this is where I have to mention that this kind of using public is kind of dog shit. Using public makes for very Hitlerite code that is terrible to use, and everyone else on your team will hate you. So we try not to use it, even though if I were to switch this to private, it would go away over here, which kind of leaves us a problem because sometimes we do want to see things in our editor, right? So we can assign values and stuff like that. And the solution to that is this tag right here that is serialized field. Serialized field is basically what you want to do for anything you want to be able to see in the editor, but you don't actually want other scripts to access. I'm assuming all of you have had like a class in OOP or that talks about like why encapsulation is important, so I'm not going to get like super into it. But the general idea being you don't want every other script to be able to mess with the internals of the script. You want the script to be able to control everything so that when you're looking for a bug or whatever, you're not like scanning your entire code base. So the next property we want to have is just another serialized field, private float, and we're just going to call it speed. And we're going to say by default, we want it to be equal to 1. And over here, we'll just get back a value, and we can multiply our left-right value by speed. And this works, well enough. But one thing like we ideally want to do is we want to make tools that feel like nice to use for everyone else on our team, right? So the only problem with this is that I could set the value to 0, and then the player wouldn't be able to move at all. I could set the value to -1, and the directions are inversed. So I don't really want the guy in editor to actually be able to do that. So what I can do is I can apply a constraint to that speed. So I can say range, and then I can give a minimum value. So I can say the smallest I want to go down is actually 1. And then the max I want to go up to is, let's say, 30. And then you'll see in editor that this gets replaced with a actual slider if Unity will compile. God, I hate this engine. So as you can see here, I now have a slider that I can use, and I can't have a negative speed, right? And it's also just a bit nicer to use because I can just kind of drag that around. Okay, so we did all of that, and now is we have a guy, but our dude cannot jump at all, right? So for this, what we can do is actually first I want to go over git component. Okay, this right here is really, really, really fragile, and that is the simple thing of what if I forget to assign my rigid body, right? And for the player controller, there should always be a rigid body here, right? So what we could say instead is, hey, I want this thing to be private, and instead, whenever the game starts, I could say RB is equal to get component rigid body 2D. And I could look it up, and I could look through and try to grab this thing right here, right? Now, some of you might have the question of just okay, why don't I just write get component rigid body 2D? And you can see my editor's already yelling at me. And the thing is that this is really, really, really expensive because this is a search for this component, and it's just it can get pretty expensive. Git component isn't the worst thing ever, but it's just you're wasting performance for no reason. So what we prefer to do is we prefer to cache something when the game starts, or ideally when it awakes, but we'll get into that later, and store that. Now you can see my editor is also giving me a few other warnings. Over here it's mad at me, and it's well, what's wrong with this? That was fine code before. And that is because Unity has its own specific naming conventions that you should follow. So for private stuff that's only in our script, we ideally want to lead with an underscore if it is private. I'm just going to rename this. And if it's something like a serialized field, or if it's a public float, then we use a lowercase and we don't lead with an underscore. And if it's a class, then we lead with capital letters. We do Pascal case, and this is the same for functions. So if you write function void do thing, this is wrong and you will get yelled at, and you should be writing Pascal case for your function naming. So sometimes we also need references outside of our script, right? And for example, we might want to mess with this camera in some way, right? We might want to get this camera and basically say, hey, I want to follow this player. Now, realistically, we would make a camera controller and have that deal with it. But for the sake of argument, let's say that I wanted a private reference to my camera. And again, I didn't want to have to rely on the fragility of looking through the entire scene. Well, what I could do is I could say camera is equal to find object of type, and then we can look for the thing that we're looking for. Now, the difference between these two is really, really big. This runs a local search, which means that it basically looks only on your object and says, okay, I'm only going to look through these few components, and that's all I'm going to find. Find object by type is a global search of the scene. So it's going to look through here. It's going to be is there any camera? It's going to look through there. Is there any camera? It's going to look through this. It's going to be oh my God, there's a camera right here. Now, that is really, really, really inefficient. And it's fine to do for one frame of a game to store reference. But you should never, ever, 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 ever throw this into here. Now, that also goes for the following bit of code. you can actually get the main camera that the game is like looking through with the tag camera.main. The only thing is that this is really expensive because it is the exact same thing as a find object by type camera. So if you are ever referencing camera.main in your project, store it up here. Do not ever throw that in update. Okay, all that aside, let's make our boy jump. So, assuming all of you know how if signal works, we can just ask like, hey, get is this key down key code space. And I realize I should actually explain the different types of get key. So there are 3 types of get key in Unity, and they all have slightly different meanings. So let's go into if input get key down key code dot space. This is going to only fire once whenever you press down the space button. So I press down the space button and it's only recorded once no matter how long I hold onto it. And it's fired the second you press down on the key. The opposite of that is get key up. What get key up is basically saying is like, hey, whenever the player releases this key. So it doesn't fire whenever you hit the spacebar, it fires whenever you let go of the spacebar. And the final one of that is get key. And what get key will return is it will return true if the button's pressed down. So as an example, if I print out player hit space once, and if I print out player is currently hitting space, oh, I cannot type right. And I go into my game, you will see that when I tap down on space, I'm getting a lot of these firing off because every frame this function right here is returning true, but I only got one of these to fire off because I only pressed down on space one singular time. So for stuff like jumps and stuff, you ideally really want to use get key down, mostly just because it's the thing that makes the most sense here. We also have get button down, and this is just kind of a more universal thing. Unity has like a default jump button, which is tied to space, but it's also tied to like a button on a gamepad and things like that. So to make our player actually jump, what we want to say is basically, hey, whenever the player hits down jump, let's right now just say RB dot add force, which we can use to give him a bunch of force at once. We want to move him up, so we would use the up vector, and then we would pick some value. I'm just going to try to speed through this. So we can basically say, hey, launch this guy up with this amount of force that we're going to use up here. And for jumps specifically, what you want to use is you want to use force mode 2d.impulse. This function has 2 different types. One of them is like adding force for like a race car, where like you're adding force over time, so it's like speeding something up. But the other type is like kind of like a jump, and that's what this thing right here means. So if I was to switch this over to force mode 2d.force, I wouldn't actually get like as much of a jump as I want. So for our purposes, whenever you use this function, just like default put this in here. So we should see I have another slider over here. Oh my god. Let's say I can jump with 20, and then if I should hit down space, the game should throw up my boy. Wow. Oh wait. Okay. Oh my god, you just learned all the basics of like Unity, but let's get into some more specific things that like will help you in all of your projects, and some general conventions that will help you. And the main place for that is UI, because there's a lot of like fuck ups that people have in UI and overall that are just kind of atrocious. So how do we actually like get something to the player? Like how do we show them health? How do we show them how many coins they have? Stuff like that. And if we were to create something over here in our hierarchy, we have an entire tab for it called UI. Just running through all these types quickly. Whenever I try to create one of these types, you can see that I get this canvas thing that appears right next to it. Also, little side thing, Unity uses TextMesh Pro, but for some reason you have to import it every time you start a new project. It's weird. But every time I try to create one of these UI components, you can see I have a canvas that it gets rendered on. So the canvas is where all of your UI shit goes. So for example, I have some text that I want to appear in game. I have to decide where it pops up, right? And all of that is done through this thing called the rect transform right here. Normally, objects have this thing called a transform, and that handles their position like globally. So this guy is at negative 0.41x and negative 0.97y, right? But rect transform tells us like where this thing is relative to its canvas. A few quick tricks that you should probably know. This button right here, if I was to click on it, you can see I have a bunch of like confusing diagrams right here. But the main thing I want you to do is I want you to hit Alt, and I want you to click on all these different positions, and you can see how it kind of like locks into place for a bunch of different areas, right? So for example, if I wanted it to be like health in like the top left corner, I might say, I might take this component, I might throw it up in the top left. And you can see it gets bounded right there. Now, one bit of advice for whenever you make a project is that you should always see how it looks across different screen sizes. And the problem with this right now is you can see whenever I have the game rendered at 4K, health is this size, but if I was to jump down to like this size, health changes depending on my screen size, which is not what we want. And this is the most common mistake I see in Unity like all the time. People forget to have the like UI scale with their screen size, and it's a very simple option in Canvas Scaler over here, which is the root of all your UI objects and stuff. We can go over here and we have this component that we can modify, and we can change the UI scale mode with, instead of constant pixel size, we would say scale with screen size. And then you give it like a default resolution. So for example, let's say the default is 1920 by 1080. And then therefore, whenever I change my screen size, it is literally always the same. It does not like get modified or like weird or whatever. And the reason that this like particularly can screw people up is like, imagine, I'm just gonna go to free aspect. You can see, oh wait, actually, let me, generally the place in it can be modified based off of the type of screen size that you use. So it's very important to scale the screen size for all this stuff. Okay, so let's just imagine for a second our player has some sort of health, right, that can be depleted. How the fuck do we show that, right? So we could say like in the corner, health 3. How can this script over here know that the player has kind of decreased in health? And based off of everything I've shown you so far, you might do something kind of like the following, right? Oh, also, I recommend always creating a folder for your scripts to throw them there. It's not like a Unity div, it's just organization. So if we are in a script, actually I should probably do this through Unity because that's going to be the same for everyone. And let's say I try to make a health UI component, and I want that to be on this text object, right? I think the default assumption is that you're like, okay, well we need like some reference to the player, right? Controller, player controller, and then we'll like ask, we'll like link this up, and then on some over here, what I'll do is I'll like say some shit like public void or int get health, and I'll throw back a number for the UI. So I'll like return 5. And then I'll be like, okay, that's cool. Just every frame, what I'll do in the game is I'll just ask, hey, player controller, what is your health? This system generally sucks, and we don't like it, mostly because we don't want the UI to be able to like break the rest of your code. which this can very easily do. So for example, a missed reference here can fuck everything. You also just shouldn't have like a direct reference to everything. And you shouldn't be constantly checking for the value of stuff in update. So the second kind of big lesson, if you're going to take away anything from this, is something called the Unity event is your friend. So let's imagine for a second that our player has a integer called health, right? And by default, it's equal to 5. Now, we don't actually want anything else to be able to look at or modify our health in any way, mostly because like it's just a thing that should be private to us, right? So how can we let everything else in the world know what our health is without actually giving them access to it? And this is where a Unity event comes in. So there's two types, and by default there's this thing, there's this just static Unity event, and we just can say like on health change. And what this allows us to do is we can hook up other functions in our code to run whenever this thing is called. So as an example, imagine I have this void called print damn that sucks whenever the player loses health. And all it does just prints out damn that sucks. And whenever our game starts, we're just going to say, hey, whenever the health changes, I want you to add a function that's going to be listening in on this, and that function will be print damn that sucks. So now, anytime that this thing over here gets invoked, meaning called, this function over here will automatically be called alongside it. So as an example, if I then say, man, my health changed, and then I want to invoke that, this just means like run, and the question mark over here means like, if there isn't anything listening in, don't invoke it. If there is anything listening in, do invoke it. This question mark is a general kind of safeguard in Unity that allows us to prevent us trying to call things that don't exist. But whenever you're trying to like call a Unity event or whatever, this is the general form that you want to use. And if I was to run the game, we would see that this function does get called, despite the fact that like nothing ever explicitly like writes out that function name like one for one. Oh, where? Oh, I forgot. When you do create these, you do need to say equals new Unity event. Washed. But it would have printed out, damn, that sucks. Now, that isn't that useful on its own because we can only, at this point, tell other functions to run. But if I was to try to give a variable here called like int new health, you can see it gets very, very mad at me. And this is where the second type comes in, where we throw in these angled brackets, and then we basically say, hey, I also want to pass along this information to anything that's listening in. So private Unity event int. And it's going to get mad at me because it will want the same thing over here. And as you can see, now if I connect damn, print damn that sucks. And new health. Oh wait, wrong one. If I invoke it, I have to pass a integer parameter, and I'm allowed to link them up like this because this over here is sending an integer, and the thing I've told to listen in is receiving an integer. Now, it isn't very useful when the thing you want to listen is on the same script, but we can kind of expand this a little bit. So let's make this actually useful. So on the health UI, let's first get acquainted with like how to edit UI through code in Unity. So let's say I want to edit this text when the game starts, and I want it, instead of saying health 2, I want it to say health 25. What I can have is I can have a reference to a text mesh pro, and I'm sorry I did not come up with this naming convention, pro UGUI. This just means this text object right here. whenever you want to reference one of these text objects and like modify it in some way, you have to get a reference to one of these. What I'm just going to call this is I'm just going to call this my health text. And what I'm going to say is health text dot text is equal to health 5. And I want a semicolon there. Now, if I was to actually like run this, and I need to drag this, you should see that like when the game starts, this text up here gets updated, right? Now, what we want to do is we want to connect it so that, imagine I have a void in here, a function called damage player, right? And what this function does, that's not what I wanted to do, is it just decreases the health by 1. What we then want to do is we want to also basically say, hey, anything else that might be like, that might react to the information that we lost health, I want to pass that information along. So we're once again going to make a public Unity event. And I know I did say that like public is evil, but specifically for events, that's fine because we want other things to be able to listen in. We're going to pass along an integer that is our new health, and we're just going to say on health changed. The convention for events is we use this on, we prefix with on, and then we say whatever happened, because it's just like the, I don't actually know why, it's just the standard that we use. So we have this over here, and we're going to say, hey, if whenever we damage the player, we're going to say anything that's listening in to on health changed, I want to pass along the new health that our player has. So over here, when we start, or should I teach about awake? Probably. Okay, there is 2 versions of start in Unity, and I'm sorry about this, but it also kind of makes sense. So remember how I initialized this component back here a while ago, right? Now, a very interesting question, we can ask a very interesting question, which is, what if this script over here is asking for some information from this script here before this script has initialized? This is a race condition, and they are a pain in the ass to deal with. So there's a very convenient way for us to deal with this. Awake is where we can set all the, get all of our shit in order before the game starts. And then start is where we want to like handle all the logic that should happen when the game starts. Which sounds really confusing, but you can basically break it down in your mind as like, okay, awake is where I should throw anything that's like using a get component. And start is where I should actually, is where I throw anything that actually uses that, right? So we could say, for example, in our own awake method on this health UI, we could say we need a reference to the player. So player controller. And we can say, hey, when the game starts, I want to set this equal to find the player in the scene. There are better ways to do this, but for now, this is what we're doing. And then in start, what we can say is, hey, player controller dot on health changed. What I want to do is I want to know whenever that happens. And whenever that happens, I want to run this function called, let's say, update text. And that takes in an integer called the new health value. And we can throw that into here as follows. So now literally anytime this is called, this is called, the code all the way over here will run. And we don't have to worry about like this code being fucked or whatever, because it's only connected to this single line right here. So let's actually update the text. And what we can say is, hey, the health text should equal health. And then we need to figure out how we can actually put a number right here. And the way C# handles this is we you throw a $sign. And it's kind of like an F string in like Python or whatever, but we just use a $sign instead. And we can say, hey, health, and you can throw around brackets. And inside the brackets, you can throw a value. So for example, 5 or 3 or 2, that will then get computed down into just like the string of it. And instead of 3 or 2 or whatever, we can write new health value. So to recap, we make a Unity event. This Unity event can have other things listen into it and basically question like, hey, has this thing happened? When something does happen, it notifies everything else that's looking into it and and runs all the functions that are being correlated with it, which we then take advantage of in our UI. Whenever you're writing UI and you want to listen into an event happening, you should be probably using a public Unity event because it is the least fragile and most like separate way of handling it, usually. So as an example, let's say that whenever I hit down the E key, hit key down E. Let's say whenever I hit the E key, I want to damage the player. And if I run my script, we should see that it starts as like health of 2, but then it decreases. What? That's crazy. Okay. So let's also talk now about just getting rid of objects and how that works. If any of you have taken like ICS 45C or whatever, you might be thinking about like the pain of like destruction or whatever, and like missing references and all that. Usually for this reason, we want to avoid like linking up objects too much because, or at least objects that we know are going to be destroyed. We want to kind of avoid linking those up too much. But let's say if I did want to kill the player, I can make a void called, let's say, kill player. And the way I get rid of stuff in Unity is I write destroy, and then whatever I want to get rid of, right? So I could say destroy this, right? And you might think that gets rid of the game object, right? But it doesn't. And again, we need to think about what scripts are in relative to the objects, right? So this is only, when I write this, I'm referring to the specific script I'm on. So if I say destroy this, what I'm saying is really get rid of the player controller. So if I was to destroy that, and let's just let that ride. So let's say if health is less than or equal to 0, kill player. And I like quickly, let's say, run through my health, you will see that like most of my player is like still like relatively intact. And you can see that my player controller is just gone, right? So how can we get a reference to our actual game object and everything in that? Well, this is what I was talking about before, what I said naming conventions are really important because there is capital case game object, which refers to the blueprint of all game objects in Unity. But then there's also lowercase game object, which is reference to the game object that I'm attached to. So if I want to get rid of like the entire like sprite render and rigid body and everything, I have to destroy the game object. Now I could also write lowercase transform right here. So I could say destroy transform, and this does the same thing because the transform is the thing that every single Unity object shares. There's nothing else you can guarantee on a Unity object. You can't guarantee it has a sprite render. You can't guarantee it has a rigid body 2D. What you can guarantee is that it does have a transform definitely. And transforms are just generally references to everything that deals with the position of your object, as well as the scale and rotation, that all is run through the transform. So for example, if I want to get my current position, I write transform.position. If I want to get my rotation, I type transform.rotation. And all of that positional information is stored in this thing right here. Whereas game object is more like, this is where this thing is in this in the hierarchy of everything. These are the components attached to it. Anyway, so if I want to get rid of my player, I type destroy game object, and we should see that if I spam E, I obliterate myself, and I like mega die. Boom, and I'm gone. Okay. I think the only thing I want to go over today that beyond that is just the a few more tags that will be probably pretty helpful for making like good looking inspector UI. Okay, so remember rigid body, right? Now it doesn't make sense that our player could have a our player controller can exist without a rigid body because it depends so much on this thing that it doesn't make sense that this would be able to exist on its own, right? And we might want to be able to have a way of saying, hey, if this script is attached to something, there should also be a rigid body on it. We can do that with the following tag that says require component type of, and then whatever you need. So like rigid body 2D. And you can see now that if I try to remove this rigid body, it's going to get mad at me because it's going to say, hey, you can't remove that because you said that you need it. And you're like, okay, but how does it work whenever I'm like trying to actually add something? So if you add a player controller and it requires something else, it will automatically bring it with you. So this is how we can kind of avoid a lot of fragile code. We can add on this tag, which will basically say, hey, I need this stuff to come along with me for my shit to work. Other tags that are pretty useful for like writing inspectors and stuff are like, for example, if I want to like break up the flow of this and basically say, hey, this is all like the movement stuff, and then this is all the health stuff. What I could write is I could say, hey, this header, I want to label this all below me as, let's say, just movement. And I want to label this all below me as, let's say, just health. We can then see over here that we now have this nice break of all these assets. And you might think that this isn't really that important, but for designers and all those other people on your team, this is really, 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 really helpful because it just guarantees, not guarantees, but it makes your shit a lot easier to read. Another useful one for your teammates is tooltip. And the reason that this is useful is because not everyone wrote your script. So not everyone knows what like underscore like cows killed means, or I guess that one's clear, but like not everything's immediately apparent. So if you throw along like a little comment of like the functions to be linked when the health changes, and you hover over it now in editor, you will actually get a good view of it. Oh, I guess it doesn't fucking work on events. Tooltip, speed of the player. Generally, the more you can make your code look like the Unity default components, the more your team will be happy with you. And you can see I have my little tooltip there. I think that is basically all I have for today in terms of like the basics of Unity. If you have like a specific Unity question of like how do I do X or Y, I can answer that. But that is like, I think, a pretty basic overview of like the kind of core concepts of Unity. Yeah.